Hello viewers, this video is heap roof members calculation. We want to learn how to calculate for the members in our heap roof. So in this video we'll be doing calculation for wall plates, the tie beam, the king post and the different type of rafters. Now, in subsequent one we'll be learning how to do calculation for struts and purlines. This is part 2 of this video. Now let's go. We'll have the roof plan, which is this. This is the top view. We'll have the cross-sectional view, which is this. If you're viewing this roof in this direction, if you have cross-section in this form, so have this cross-section. Let's say section AA or section. Let's say section AA. Alright. So let's start with our member, the wall plate. In heap roof, the wall plate will run across this length from this point and also from this point to this point. We will not have wall plates across the width of the plan. So for wall plates, this is what we're going to have. Wall plate will have the length from here to here is 10.8. Because it's 2, this and this will multiply by 2. We'll have 21.6. That is for wall plate. Then for tie beam, for our tie beam in our heap roof, let's use the top view. The tie beam is going to run from this point. From this point to this point, you have your tie beam where you have your struts. So from this point to this point, if we use house span rule for this design, it means from here to here, using our ground floor plan is 3.6, here is 3.6, here is 3.6. In this plan, this point here is 3.6 because the width of the building is 3.6. Here also is 3.6. And it means from here to here will also be 3.6, making total length of what? 10.8. So if from here to here is 3.6, then let us get the total number of tie beam. So for us to get the total number of tie beam, we have to say 3.6 divided by the spacing center to center line, which is 0.9. For tie beam, 0.9 plus 1, we have 5. Total number of tie beam is what? 5. For us to get the total length, you have to multiply by the length of 1. The length of one tie beam. One tie beam will run across from this point to this point, across the width of the plan, which is what? 3.6. So I'm using 3.6 as length of one tie beam multiplied by the number 5 to give me 18 meter, 18 linear meter. So for tie beam we have 18 meter. So alright, let's quickly proceed to king post. So for king post, we are going to have the king post run from this point to this point. Where you have your strut is where you see your king post. So from this point to this point is our king post. So let's get the total number of king posts. From here to here is 3.6 divided by the spacing. We say 3.6 divided by 0.9 plus 1 will give us 5. So from here to here we'll have 5 king posts. So the height of one king post is what? Let's check from the cross section. See, from this point to this point they have given us 1.8 as height of one king post. So it means we are going to multiply 1.8 by 5 to give us 9 meter as the total length of our king post. So having done that, the next thing for us to do now is for us to go to our what? Rafters. You know, in heap roof we have different type of rafters, but for this plan we just have 3 rafters: common rafters, heap rafters and jack rafter. We have other types of rafters. So let's start with common rafters. Now, common rafters is these ones, these rafters that run from this point to this point. These are common rafters. They also have this one that divide this heap into 2. From here to here is a common rafter. From this one to this point is a common rafter. So let's start with this first. Let's use this cross section to get our common rafter. From here to here is 1.8. From here to here is half of the span of our plan, which is what? 1.8 also. So we're looking for this one, which is this x. I'm using Pythagoras theorem to get x. So when you solve it out, you have your s to be 2.5. It means from this point to this point is 2.5. So having gotten 2.5, now we have gotten the length from here to here. So let's get the total number. What then will become the total number of our rafters? So the rafter is spanning from here to here, which is 3.6. We say 3.6 divided by the spacing. 3.6 divided by spacing plus 1 will have 5 rafters. So because it's two sides, this and this, we multiply 5 by 2, have 10. So we use 10 to multiply the length of one rafter, which is 2.5, which is this. We'll have 25 meter length. So for the common rafter, these ones will have 25 meters. So let's go over to which other one again? Let's go over to this other one, this, that divide the heap into 2. So for that, we have our king post is from here to here, which is 1.8. So from this point to this point is 3.6. Then this lantern length is x, is what we are looking for, which is this, is what we are looking for. So we have 3.6, 1.8. We use Pythagoras to solve that. So we end up having 3.6 square plus 1.8 square, or s is giving us 4 meters. From here to here is 4. So because that common rafter is just 2, it's just this and this. So I'm multiplying this length, this 4 meters by 2, I have 8 meters. So the next rafter we're going to talk about is our hip. It's our hip rafter. Our hip rafter is this, that this one that run from this point to this point. This one is our hip rafter. So for our hip, we have this common rafter to be 4 meters. We have half of this. From this point to this point is 3.6. From here to here will be 1.8. So let's go. So for our hip, we have from here to here to be what? 4 meters. Then from here to here is half of the span, which is 1.8. Then this hip is what we don't know, is what we need to calculate now. So from here to here is what we don't know. So let's use Pythagoras to solve. Pythagoras theorem to solve. So when you solve it out, we have 4 square plus 1.8 square. When you solve it out, we have s from here to here to be 4.3. Because our hip is what? The hip rafter is 4. I'm multiplying it by 4. 4 times 4.3 will give us 17.2. This is what I mean. You see your hip. 1, 2, 3, 4. So let's proceed. The next rafter we're going to calculate here is our jack rafter. Our jack rafter. So in our jack rafters are these ones. These ones are run from this point to this point, from this point to this point. It's our jack rafter. So we can produce something in this form, this shape, so it will aid us to calculate for jack rafter. So it means we have this shape. From this point to this point is half of the span, which is 1.8. This is our common rafter, which is 4 meters. So I think this length is not important in this calculation. What we want to know is the length of one jack rafter. So now, in this plan, when you look at this plan, you see that if you move from this common rafter, you move some distance, you get one jack rafter. From this point, you get another jack rafter. From this point, you get another jack rafter. So you see that how many jack rafter we have in this plan? 1, 2, 3. So we have to check the spacing. We have 1, 2, 3, 4. So we divide the half of this span, which is 1.8 by 4, to get this spacing. So from here to here, if we divide by 4, we'll get 1.8 divided by 4, we'll get 0.45, 0.45, 0.45, 0.45. So I've gotten the spacing between these jack rafters. So for us to calculate for each of these, A, B, C, now we treat separately. Let's treat this right angle triangle separately. I produce something like this for us to solve A, which is this. I have known this. I know the angle of the roof to be 45 degrees. So I'm using SOHCAHTOA to find each of these lengths. So I'm using tan theta, which is what? Opposite over what? Adjacent. So this is the opposite I'm looking for, which is A. The adjacent is from this point to this point, which is 0.45. So if I solve A out, I have A to be 0.45 meters as my A. So I go to length B, this point. I'm treating this one separately. So I produce something like that. It means from here to here, this place have to be increased by 0.45. So 0.45 plus 0.45 give me 0.9. That's why I have tan 45 equals to B over 0.9. If I solve B out, I have 0.9 also meter. Then let's go to C. C, I'm treating from this point separately. So for C, I have tan theta equals to C over 1.35, because from here to here is 1.35. So tan 45 degrees is 1. 1 times 1.35 will give us 1.35 meters. So for us to get total length of our what, we have to add this, and this, multiply by 4.